Esteemed Kaavish committee, today I am here to present you Team Zaamin. So a problem that we particularly were really aware about were three different things. The first one was that CCTV cameras are much more commonplace than they ever were before. However, their utilization is at an all-time low. To add to that, CCTV systems are very labor intensive and require 24/7 manual monitoring. And that puts us at a risk of human operators missing out on unwanted events just because of their decaying performance. But then what about intelligent cameras? So far, the solutions we have seen have been memory intensive, computation intensive, and very difficult to deploy, leading to a lack of solutions in this particular space. Which is why we propose an AI-powered video analytics software that does four major things. Number one, it's real time, so that it allows people to get insights right then and there in the moment. Our system is also object focused, which means that it uses discrete objects and predictions based on those objects to provide insights to the user. We created an alert-based system as well, which means that every time a certain threshold or a rule or a zone or a boundary is crossed, an alert is generated, so the user is instantly made aware of anything that they did not want happening in the first place. And finally, we ensure easy deployability, which means that no additional hardware setup will be required to ensure proper functioning of this system. In terms of relevance, we see that there is a significant need for automated SOP monitoring and enforcing, which has not existed at the very least in commonplace in Pakistan. And we can do that through our particular system by identifying non-compliance of social distance mandates, by analyzing distance between individuals. Secondly, we see that this particular system can actually be used in exam invigilation to detect objects that are not allowed in an exam room, such as a smartphone or a calculator. We also see this tool helping a lot in crowd management by helping any public space owner or administration understand the number of people in the space at any given time and ensure that there is no congestion, or if they need to do so, they can also get a demographic analysis up to a certain probabilistic range. Another relevant point is the provision of more security. So whether it is suspicious behavior like a person loitering or a dangerous item such as a weapon, the system is able to detect it in real time and inform the authorities right away. Finally, we see that no unauthorized access can happen through the use of automated access control. And that will help us ensure that we don't need physical presence of a security guard all around the clock, which leads to reduced security costs. However, in pursuit of this particular solution, we see that there is a huge problem. The number of parameters in ML systems throughout time has been drastically increasing, far more beyond the Moore's law, which means that we have models that are really large, but no hardware keeping up to support these advances. And while in previous research, we have seen that there have been approaches to use adaptive resolution for optimization, or try to pass a data through a lightweight model first and then decide whether the data needs to be passed through a heavyweight model in order to ensure that no additional computation is taken place. We have also seen other optimization techniques like cross region of interest, as well as video surveillance using faster RCNN technology, which is created by Facebook. And finally, one of the major parts that we'll also include in our research and has been also researched before is quantization and pruning, which is the idea of reducing model size and model precision to make it more hardware friendly and ensure that the inference speed is far faster without sacrificing a lot of accuracy. Which obviously leads us to the novelty that we're producing, which is compressing these particular models that we've just mentioned to provide additional security without actually requiring a lot of hardware, and ensure that we optimize it to a point where it does not require any high-powered device, which includes mobile or full-fledged PC GPUs. And that allows us for the real-time analytics, which is the secret sauce of our whole project. In terms of the CS contributions, we see ourselves contributing in three major ways. The first is the computer vision aspect, where we will actually be building a state-of-the-art CNN architecture, which will act as a single backbone for tasks like object detection and object tracking. This will actually allow us to reduce a lot of the computations and ensure that our models are optimized and only receive the data that they need to process. Secondly, we will also be performing transfer learning on some of the most efficient models out there in order to recontextualize them in a local Pakistani context. In terms of the software architecture, we will be building a microservice-based architecture that will create a backend that will work through API request, allowing for us to decouple the whole application and making it easily more scalable and implementable as well as deployable. We also will be using messaging services like Redis and Kafka to ensure that the real-time analytics and predictions are happening as fast as possible through the use of these technologies. And finally, the model optimization part will help us reduce the size of the state-of-the-art models that we previously mentioned and ensure that we can provide the same level of accuracy while still being less computationally expensive on low to middle-end hardware. In terms of the scope and deliverables, we see ourselves delivering a platform that will do three major things. The first would be that the system would allow inputs from 4 different sort of categories. The first could be a webcam, another could be a video file, and the other two could be security surveillance camera footage that is either coming through RTSP protocol or coming through IP video. We will then process it and then allow the user to set rules for their models and mark different zones or create lines so that these rules can be run against the footage and our predictions. And that will finally result into visualizations as well as real-time playback of the video with the tracking and the predictions being visualized, along with additional relevant data graphed out for the user to get a better insight into what's going on in their feeds. Diving a bit deep, what will happen in terms of the technical sense is when a video is sent in, we will be sending it to a web server, which will encode it and then send the encoded footage to a model server, which will, based on our API request, process the footage for only the specific models and predictions that we need, and then send those results back to the web server, which will then crunch the numbers and help provide visualizations and predictions to the user directly. The results from the model server will also be stored in a separate database to allow for historical access for these sort of predictions. Coming on to the feasibility, we actually are very privileged in the sense of the tools and the resources we have available to us to enable our goal of creating a real-time analytics system. Primarily in machine learning, we will be using 4 major modules. One is TensorFlow, PyTorch, Caffe2, and Neural Magic. All of these will help us develop state-of-the-art machine learning model without loss of a lot of performance while still being computationally inexpensive. These models that we'll create will be trained on these 4 main datasets, apart from additional dataset that we will generate on our own through local sourcing. So these 4 datasets are ImageNet, Coco, OpenImages, and Cityscapes. The Cityscape dataset is different in the sense that it does also have segmentation annotation. And we see ourselves using this dataset to see if there is any efficacy of putting in segmentation in our analytics system as well. Moving on to the computational capabilities, we are looking at 3 different mediums. The first one being cloud compute, which will obviously be provided by Amazon Web Services. We also have access to a few personal laptops that have NVIDIA GPUs in them, but they're obviously not as powerful as those available on Amazon Web Services. But we're also exploring NVIDIA's embedded AI platform called NVIDIA Jetson, particularly the NVIDIA Jetson Xavier NX. These provide us with enough computational capabilities to not only train our model, but also optimize our models further while pruning and quantization, and then ensure that they're equally easily deployed on different systems as well. In terms of the software stack that we'll be using, we have Electron and React for the front end, while the back end will primarily be developed mostly in Python and JavaScript using the Flask and Node.js frameworks. Here is a Gantt chart that actually describes the roadmap that our project Zaamin will be taking. We see ourselves getting done with all of the major aspects, including the UI prototyping, the UI development, as well as the backend pipeline development and the model integration by the end of this particular semester. As for the next semester, we will then be wrapping all of our work up to further finesse the UI, develop that, integrate more models, enhance our neural network backbone, and ensure that we properly set up our messaging broker system, and then finally continuing with model optimization, with then testing and debugging as the final step. And once all of that is done, we will be ready to present the final state of Project Zaamin, along with the report and an accompanying poster and video. With regards to the team, there is me, Arhum Ishtiaq. I have 3 years of experience in project management and development with a very specific focus on computer vision technologies. I have also been the co-founder and chief technical officer of Connector, where I have experience in technical infrastructure, financial reporting, and startup legalities as well. We have Sara Mahmood, that has had a year-long experience as an AI developer with a particular focus in computer vision and natural language processing technologies. She is currently a data scientist at Affinity for their AI production department. And similarly, she has also worked with Habib University as a backend developer for their COVID-19 dashboard. Maheen Anees has experience with web front-end technologies and has been a UI UX designer for the Habib COVID-19 dashboard. She also has 3 months of experience as an AI development intern, with her responsibilities including building and testing out APIs through microservices. We have Khubaib Naeem, who has had 3 months of experience with React, 6 months of experience with React Native, and more than a year's experience with JavaScript. He has a minor in mathematics and has also been a TA for courses like probability and statistics, and is currently a TA for deep learning. Finally, we have Neha Jafry, who has worked on 3 web development projects on both front-end, back-end, using technologies like Angular and Flask. She has had experience in AI development with a particular focus in natural language processing, and she has been a former TA for data structures and algorithms and is currently TAing the course Object-Oriented Programming. And that has been the presentation from our end. Thank you so much for taking the time to listen to this presentation. We'll be more than happy to answer any questions and concerns that you may have.